believe it would be best if I were to do a summary of the 10 videos, alright, but not in a long way, but rather in a short way to introduce what are the individual videos they're talking about. Alright, at the first video, alright, we actually introduce you, telling you that be very careful, we're gonna derive the easy way of f equals to ku, not EA over L. Okay, not EA over L. We are deriving easy way of f equals to ku. Alright, which is also explicitly defined inside your mind map over here. And then in the next video, we actually say that we're gonna do the strong form, right? So in the particular next video, this is the easy way. And then in the V2 video, we're gonna we actually say that we're gonna do the strong form. Alright, maybe I should write properly. Right, we actually derive the strong form. And then for this chunk over here, alright, we actually derive the weak form. Alright, which is also being reflected in your mind map over here. While the weak form, the first video of that, meaning l8v3, alright, so far if you still don't understand what I mean, is that I'm talking about the l8v1, v2, v3, which is you can access to your playlist also. So your l8v2, you took a strong form. For this video, we took the strong form and then we rearranged to become somewhat a weak form formula. And then we introduce you the Galerkin's method by introduce you the shape function. Shape functions input into as your W, your weighting functions. You can be any functions. Alright, and therefore using that one, we actually introduce you with a certain understanding in terms of force 1 and force 2. Right, some equations, correct, in the l8v4. And then after that, we actually write the forces with their own equations in terms of F equals to KU, right, the formula that we have been using just now, which is this one. This is the weak form stuff, correct? And then this is in fact the weak form already, so these are all the weak forms. And then afterwards, the l8v6 video, we actually want to clarify with you about the displacement interpolation and the geometry shape function properly. Alright, so this is some clarifications video, that's all. Alright, for this case over here, in this video we talk about the interpolation and we also talk about the shape functions. And in this video we talk about the explanations on how to apply the shape functions. Alright, the more on the application side. Okay, the meaning behind the shape functions. Okay, and therefore if you were to go into the mind map, alright, the first few videos we actually do the easy one, we do the strong form, we do the weak form. Alright, and then we actually went into the displacement interpolations and the geometry shape. Alright, and we have shown you, okay, which is within these videos. And then we also show you that if you were to mix the geometry shape functions, alright, together and put them all together, you can create a Jacobian geometry shape can create Jacobian, the factor. We call this the Jacobian factor. The factor. Okay, so we actually use the Jacobian factor. We actually prove to you that we actually prove to you Jacobian factor. And then we also tell you that the Jacobian factor will be later on be utilized in your together with your Galerkin's method, which is the equation that we have shown you over here using the Galerkin's weak form method to finally derive your K is equals to EA over L, your stiffness matrix for simple bar element systems. Alright, if it's a 3D system, then it's totally different case already. Alright, so we actually talk about the Jacobian. Alright, and this last video, we actually took the Jacobian. We also took some of the understanding of the shape functions. Maybe not, we just took Jacobian only. And then mix together with your general equations. These two comes together to give you your EA over L. And then the stiffness matrix, 2 times 2. Alright? And therefore this shows clearly inside your this thing also. So we uses the Galerkin's weak form method and your Jacobian together to prove to you your EA over L stiffness matrix. Okay? One thing you may go into your mind is that what is Ries's method? Raised method is something that deals with another. If you remember, there's a w over in our weak form when we introduce the certain weighting functions. So in this case, the weighting functions is some other functions. So using the raised method. Alright, I think you have actually done before. So I believe, because I have done before. Alright, anyway, so this is just some form of summary to introduce you how this thing is being worked out. But just to take note is that, alright, is that this equation over here, alright, that comes from this video, alright, is this equation. It's a very powerful equation. It's going to be utilized for all other shapes. Right? Currently what I've been using is only the interpolations of this one over here, alright, which is n1. Alright, we're at node 1 and then node 2. Okay, so these are the things that you may need to really consider. Alright, and this is the very powerful equations you're going to use later on, I think. So definitely I believe that this 10 videos has conveyed to a certain extent that it's pretty good. Not too good, but something there. And I shall see you soon. Goodbye.